Hi, this is another episode of the On.NET Show. Today we're going to be talking with Chris Gillum about Azure Functions. How about you quickly introduce yourself?
Hi, I'm Chris Gillum. I'm an engineer on the Azure Functions team, and I work on a lot of areas. Right now my main focus is on Durable Functions, which is a new extension to Azure Functions that allows you to write basically workflows or orchestrations using C# and .NET.
Okay, so what does this term durable mean?
Yeah, so durable basically means that, suppose that I'm writing a function and it needs to do multiple things. Maybe you have a process that's broken up into multiple functions, you receive a document, maybe you need to do some processing on that document, then you need to maybe upload it somewhere else, then maybe send an email, some kind of an orchestration. Durable means that for each of those steps, we're going to basically checkpoint your state automatically so that, if the VM goes down or, somehow the process gets interrupted, we're able to kind of bring it back up and resume from where we left off.
I see. I don't know if you're familiar with this term, but there's this computing concept called coroutines. Mm-hmm. This sounds a little bit like cloud coroutines to me.
Okay.
Maybe that'll be helpful for some of our listeners. Okay, so how long has this service existed in Azure?
Yeah, so Azure Functions has been around for a while. Durable Functions, this extension particularly, we just launched this in preview in October.
Okay, so it's pretty new.
It's fairly new, yeah. Some people may have seen we had like a kind of a pre-public preview alpha release.
Pre-preview.
Yeah.
So how about we talk a little bit about use cases, why people would use this, and also, since it's pretty new, where you are seeing kind of the first early adopters with durable functions. Mm-hmm.
Yeah, so there's several use cases that I like to talk about. In fact, I even have a couple of drawings that I may share if that's okay as well.
Yeah, let's do some drawings.
In fact, or even just kind of PowerPoint slides. I'm going to go ahead and skip over to a previous one here. But one of them is, like I described before, let's say that you like to use functions and you've got a bunch of several functions which implement some step in a sequential process, and you want to chain those together. Like I mentioned, you get a document, maybe do some processing on it, upload something somewhere. So that's one example of how you might use durable functions, is to kind of implement that. So here in this picture, I've got F1 calling F2, calling F3, so on and so forth.
Right. In this particular picture, though, if this was all fire and forget style computation, then F1 wouldn't need to be durable, right? Isn't it only the case if F1 was if each one of these was waiting for their caller return and then it kind of came back all the way back to F1, that's the case where durable functions would be important. Is that right?
Well, even if you're just going kind of in one direction,
fire and forget.
This is still useful for the durability. For example, if you're on F3 and then the node just dies,
oh, I see.
You want to be able to come back, continue where you left off with F3, and then get to step F4 there. I
see. So durable functions is both this kind of idea that you can kind of be idle, that's probably slightly the wrong term, while you're waiting for your the functions that you're calling, but it also enables you to have some reliability characteristics that would have been more difficult before. Is that fair?
Sure, yeah, absolutely. It might even be helpful if we jump in and just look at some code.
Sure.
Instead of pictures. So that picture that you saw, basically, I have implemented here as a simple function. So durable functions, again, this is just Azure Functions. So if you're already familiar with that, this won't be too surprising. This is our Visual Studio experience. So a durable function has what's called an orchestration trigger. Basically, we have a NuGet package which you can get to get started with durable functions. If we were to look at my CS proj here, you can see Microsoft Azure Web Jobs Extension Durable Task. That's what we call it, named after the Durable Task Framework, which we depend on. And basically, there are a few methods that you can call in that. Call activity async basically is going to take a look for some other function within your project, and it's going to call that function and pass in whatever input that you tell it to. So in this case, say hello as an example, and here's the say hello function, which is conveniently here.
I see. So there's kind of a registration story of sorts at play here. So call activity async, I guess by default, looks for functions in your same project. Is it possible to find functions that are not in your project?
Not today.
Okay.
Right now, the experience we're focusing on is the ones that are within your project, because then we can easily do error handling and say, hey,
Okay.
you have a typo or something that's not in there.
Okay, makes sense. So if we were wanting to share function logic, at the moment we'd have to be sharing source as opposed to kind of sharing live functions.
Yeah, source or DLLs, since these
Sure.
get compiled into
Sure,
DLLs.
sure.
But yeah, effectively, yeah.
Okay.
And just to be clear, we talked about durability. Somebody who's just looking at this code might be asking, well, why am I calling this say hello by name using this API here? Why don't I just make a regular method call to it? I mean, it's right here. It's in my project. What are you giving me with this thing?
Great question.
So to answer that is, we're giving you that durability, right? When you call activity async, under the hood, we're going into Azure Storage and making a record that, okay, somebody scheduled this say hello call. And, we invoke it, we get a response, we save that response. And so now, when this orchestrator function resumes, we've recorded that, all right, we've called say hello and passed in the first parameter Tokyo or something like that. And so if this process were to go down and to come back up, we can replay this orchestrator function from the beginning. We call activity async again, as part of this replay. We know that, we've already said hello to Tokyo. Let's skip that. In fact, we know what the return value was. Let's just grab that and then move on to the next step.
Oh, wow.
Immediately. So that's kind of where that durability comes in. And one other advantage you get over this model is that scale out. So let's say you've deployed this to Azure. We support durable functions natively in our Azure consumption model. When you call say hello or any function that you want to call, that could be run on the current machine that's running your orchestrator, or it could be called on some other machine elsewhere in the data center.
Right.
And so if maybe you're doing a whole bunch of calls in parallel, those could be fanned out on a whole bunch of different machines. And so that's something you wouldn't get if you were just making a regular method call into
Right.
say hello
So effectively what I'm hearing is you can kind of load balance, and it sounds like the system does this for you, on a function by function basis. You don't kind of have to load balance across your whole project, right?
Yeah.
That makes sense. And we also get reliability across these two different things. There's two here.
Yep.
Makes sense. So I guess we talked a little bit before about orchestration. Are there different orchestration models that this system allows?
Absolutely. So this is the basic one, which is I just want to do something in sequence.
Right.
Very easy, maybe not even that interesting. Where it gets more interesting is in this other sample that I have, which is about fan out and fan back in. So just so I can show a picture real quick before I jump into the code.
Okay.
Let's imagine we have this picture. You've got some function which basically needs to fan out and do a whole bunch of work in parallel. And we'll call that F2. And then all those things are happening in parallel, and then maybe at the very end of all this parallel activity, I need to go in and do some aggregation thing. Let's call that F3. And these blue cylinders here just represent typically some sort of a state that you'd need to coordinate all of these different things.
Okay.
So if we jump into the code, here's kind of an example of that. Which is basically it's a I need to back up a bunch of files. So for example, in this case, first thing that this function does is it says, hey, give me a list of files. Right? So we have some function that goes and collects the list of all the files that I want to back up. Now I'm doing a for loop and enumerating all of those files, and I'm calling some other function which goes and copies them into blob storage. Now, you'll notice that call activity async returns a task.
Yeah.
I'm not awaiting that task, so I'm creating a list of tasks right now. And then at the very end, I'm doing a task.whenAll and
yes.
awaiting on that.
I have written this exact code before.
Okay, great.
Yes.
And that's the hope, that this will be really familiar to people who've used the task library before.
Absolutely.
And so what's going to happen here during the await is the function is going to go to sleep. So if you're familiar with our consumption-based billing model in Azure, you pay only when your function is running. And so we've scheduled, potentially hundreds of function calls in parallel. Then this one is going to go to sleep and wait for all of those other tasks to complete.
Okay, so it's almost like line 36 here, the task.whenAll. It's almost like you run that line for free. That's kind of what I hear you saying.
Yeah, and this is the really interesting kind of orchestration pattern. The fact that you can do a whenAll on a bunch of distributed tasks that are running on who knows what number of VMs out in the cloud. And as soon as those are done, this task that you're waiting is going to resume.
Yeah.
You have the list of all those tasks, and so if you want to do some aggregation, like the sum, in this case, we return like the number of bytes that we uploaded to blob storage. I can get that number, and I can go and return it, to the caller.
Awesome. I mean, that sounds like a ton of value for customers. I'm actually pretty impressed. So basically, right. So you'll be, say you had 100 tasks. Yes, the files array was 100 elements long, and so this service is now put to sleep, and then those 100 separate service calls, if that's what it is, are running, and then the durable framework or some part of Azure understands that the last one completed, and then it wakes this back up.
Yes.
Awesome. And so you're not incurring any pricing costs during that time for this service.
That's correct. Yeah.
Nice.
No double billing for you.
Yeah.
So
what has the reaction been to that particular part? Because this is obviously new.
Yeah. So the reaction's been super positive because previously it was really hard to do things like this, especially in a distributed environment. You'd have to provision a bunch of tables and, write to those and keep track. Okay, what are the tasks that I started? What's the state of everything? Okay, is it, maybe I have to do some polling to figure out, okay, are they all done so I can start the next step? In this model, you don't have to do any of that. It's kind of all that state management that you had to do is kind of handled internally by the framework.
Makes sense. Can you tell us a little bit more about the actual API? So you've shown us really just one API, which was the
call activity.
Yeah, the call activity async API, and obviously all the other APIs like task.whenAll, they're just framework APIs.
Yeah.
Are there any other APIs beyond the attributes that you like? I guess durable orchestration context is one, but that's kind of just the context that you need to work with.
Yeah. So you have the orchestration context, and let's see what's another good one. So one thing I haven't actually shown yet is how do you actually start these orchestrations? That's probably a good API for me to go to.
I would agree with that.
So I'll jump to this HTTP start. So basically what this function is it's just an HTTP trigger that I wrote, which allows you to start some orchestration function by name. So you just send in, this is just regular HTTP trigger. I declare the authorization mechanism that I have for it. It takes in a post request. I've got some route, if you're familiar with Web API routes, and this is very familiar to you.
Definitely.
And I've got this durable orchestration client. So this is an important API as well. And the main thing that you will typically do with that is start a new orchestration. And so then you just pass in what is the name of the orchestration you want to run, what is some input. So that backup site content one, would be an example of, hey, I want to run that one, and you're going to get back some sort of an instance ID. Now this instance ID is important if you want to kind of monitor what is the state of this orchestration that I just ran, because if I'm backing up hundreds or thousands of files, maybe it's going to take some time. Maybe you want to be able to check on the status of that. Maybe you want to terminate that. So we have a bunch of APIs that'll help you with that. So I'll just F12 on this client and see what I get back here. Yes, it's one of my favorites. So we have APIs like, hey, I want to get the status of my orchestration. Is it still running? Did it fail? Give me some more information. Or maybe I want to terminate it.
Okay.
Because hey, there's a bug in this. I need to stop it.
That's a little bit like cancellation.
Yes, a little bit like cancellation. So you get a few things like that, and some more advanced ones like raise an event. These functions have the ability to kind of stop and wait for some event to be sent to it.
So how do exceptions work? So
great question.
Yeah. So if you're T1, F1 is what I meant to say, and you call into F2, there's an unhandled exception in F2. What does that look like from the perspective of F1? Is it just like tasks?
Just like tasks. So again, this is just regular C# code. So if some function throws an exception, basically this call activity async is going to turn around and throw an exception that you can catch and have some whatever logic you want to do, compensation.
Right. So I guess if you have a badly written set of functions, you could be like in that first picture. You went all the way to I think F4, F5. If in that one you have an unhandled exception and you didn't handle it, it could come all the way back and your whole set of functions could fail.
Yeah, potentially. You could determine how you want to handle that if you want to handle it. We also have some, going back to APIs a little bit, we have another version of call activity async that takes in some retry parameters as well.
I like that.
So if you want to, and sorry, I don't have a demo ready right away, but we can just kind of wing it. Let's see, we have looks like it's the second parameter here. We have a retry options parameter that you can specify. And that's going to allow you to say, if I want to automatically retry, if you have badly written functions or you're calling some service, some external service and it's flaky, you can specify like, hey, I want to retry this up to 10 times and I want to wait, 5 seconds in between retries, or maybe I want to do, kind of an exponential back off. We have APIs that allow you to kind of do that. And so you can explore the docs and see all the different config knobs there.
Right. I guess you could also have code that basically you could have a catch handler, and for some types of exceptions, you would manually retry, and for other ones, you would just give up and say like, oh, I know this is like a unrecoverable state, so I have to do something different.
Definitely.
Okay. So you talked about there are some NuGet packages for this service. Could you actually show us those again so people who are watching from home kind of know what to go look for?
Absolutely. So I'm just going to go back into my project file. So this is, so if you're familiar with Azure Functions, this is an Azure Functions project for Visual Studio. So normally when you create that, you're going to get this Microsoft.NET SDK functions.
Okay.
And that basically tells Visual Studio that, hey, this is a function app, and if I F5, then I'm running the functions host locally.
And so this is a stable package. It looks like it's not a preview one.
That's correct.
Okay,
yep.
Good.
This is stable. And then for durable functions, we have another NuGet package that you can reference, which is going to give you
preview.
Yes, and that's going to give you all the functionality that we talked about. We have both support for the full .NET framework. We also support .NET Standard 2.0. So, the attentive viewer will notice that I've got some, conditional checks here, like, am I targeting .NET Standard 2.0 or am I targeting full framework?
So would the guidance be that if you have fairly simple needs, simple is not quite the right word, basically if you don't need any APIs that are in .NET Framework, that, and you don't need any specific APIs that are in .NET Core, then .NET Standard Functions would be the way to go?
Yes, and I should clarify too that as of right now, .NET Standard support for functions is in preview.
Okay.
Whereas the full framework is completely supported.
Got it.
So you're going to get as of right now, you're going to get the best experience if you target the full framework.
Okay.
But if you want to do things like I want to do development on a Mac or Linux, local development, then .NET Standard is obviously a choice that you want to go with. And that moving forward, that's what we're going to be primarily supporting.
Makes sense.
Standard.
So from an operating system standpoint, you just mentioned operating systems.
Yeah.
Do I need to think about, am I going to deploy this into a Windows function versus like a Linux function, like you kind of have to with Docker containers? Or is it agnostic?
So you to some extent, you do have to know.
Okay.
Right now, so for the local development experience, we wanted to make sure that we don't exclude anybody. So with our .NET Standard support, you can do it on a Mac, on Linux, or on Windows. In Azure, if you're deploying this up to Azure, today we only support running functions on Windows. So you just have to be careful especially if you're targeting, that you're not trying to do anything that's platform specific. And if you're doing .NET, you should probably be fine. I think most people who target other languages like Node might, some things you have to be aware of. But in Azure, we just support Windows today.
Right, and one place that people sometimes get tripped up is the different slashes in the file system, but with functions, that's probably less of a concern, because I assume for the most part, you're not hitting the disk in the traditional sense. Is that right? For
the most part, yeah. I mean, you can if you want. We have disk there, but you usually don't need to use it.
Makes sense. Okay, well, I think we should kind of close up here. I think we've had a great deep dive into durable functions. Mm-hmm. Is there anything you kind of want to close with? Any, call to action, or go over a couple key points?
Let's see. I guess definitely it's in public preview. Try it out. This is all open source as well, so it's on GitHub. So I believe the repo name it's under the Azure organization. Let's see, Azure-Functions-Durable-Extension.
Okay.
So go check it out. Open up issues. If you have anything, or even have just questions that you want to ask about this, we actively monitor it and are very engaged there. And we just love it if people could use it, try it out, see if it works for your use case, and check out the documentation as well. Just search for durable functions online, and we've got lots of docs to help make sure everyone can understand it. Yes.
Okay, great. Well, thanks for coming, Chris. This was certainly enlightening for me.
Oh, good.
So this has been another episode of the On.NET Show, and today we were talking about Azure Durable Functions. Thanks for watching.